Welcome to this explainer. Okay, today we're diving into the absolute mind-blowing science of why ice floats. I mean, we see it literally every single day, right? But the molecular magic of water completely defies how almost every other substance in the universe behaves when it freezes. It's basically a daily miracle just sitting right there in our cups.
Seriously, did you know that frozen water floating on top of liquid water is actually a bizarre scientific anomaly? Just picture an ice cube falling into a glass of water, splashing down and then boom, bobbing right back up to the top. We see this in our iced coffees or our water glasses all the time, but we rarely stop to ask why water breaks what seems to be a fundamental rule for how matter transitions between states. It's this everyday occurrence that we just completely take for granted.
Section 1. The ice anomaly. Breaking the rules of physics. Let's get right into it.
So, normally, solids sink in their liquid counterparts. Think about it. When almost any other substance cools down and freezes, its kinetic energy drops. The molecules lose that energetic bounce and they pack tightly together, making the solid denser and way heavier than the liquid form. And because it's heavier, it sinks straight to the bottom. But water? Water plays by its own rules. Ice floats on top of its liquid self, which is a stark contrast to the rest of the natural world. It operates completely backward from what standard chemistry dictates for most materials. Crazy, right?
Moving on to Section 2, Inside the Molecule, zooming into the invisible world.
So as water cools down and eventually freezes into a solid state, something highly unusual happens. Thanks to hydrogen bonds, the water molecules actually spread apart. Yeah, instead of losing energy and packing tightly together like we see with most normal solids, they lock into this rigid, open, crystalline lattice structure. Imagine a really precise hexagonal arrangement where the molecules are basically holding each other at arm's length. They literally enforce a strict distance from one another as they lock into place.
Which brings us to Section 3. The density difference. The key to buoyancy.
Okay, because those water molecules spread out into that open hexagonal structure, the solid ice ends up taking up roughly 9% more space than the liquid water it originally came from. It's the exact same mass, but stretched over a much larger volume. And hey, more volume at the same mass, that means less density. The physics equation here becomes beautifully simple. Less density equals floating. It's all about how much material is packed into a specific amount of space, and ice is simply packing less stuff into that space compared to the liquid water right beneath it.
Section 4. Saving aquatic life. Why this molecular quirk matters.
Now let's look at the big picture. If ice actually sank, the consequences would be pretty much apocalyptic for nature. Just picture a massive lake in the dead of winter. If that newly formed ice on the surface dropped straight to the lake bed, lakes and rivers would freeze completely from the bottom up. Without that floating layer of ice acting as a protective, insulating blanket on the surface, the freezing winter air would just keep freezing the water downward, layer by layer, until the entire body of water became one solid block of ice. Aquatic life simply wouldn't survive the winter. I mean, it would be a total death sentence for ecosystems everywhere.
This whole thing leads us to a pretty profound realization. Nature designed water in a very special way. This isn't just a random piece of trivia. This molecular anomaly, where water molecules spread apart to create less density and float, is actually Earth's ultimate brilliant survival mechanism. Science is truly amazing when you step back and realize that this microscopic quirk is exactly what keeps our planet alive during the freezing months.
So, I'm going to leave you with this to ponder today. If water is uniquely designed to act completely counter to standard physical behavior just to sustain life, what other invisible, microscopic miracles are happening around us right now? Keep looking closely at the everyday things around you, because the science operating just beneath the surface is nothing short of amazing. Thanks for joining me on this explainer, and I'll see you next time.